Section 6.5 has to do with parts of similar triangles. Very similar to the last section that we did. This one has to do with particular proportion things that are going to be proportional the same way that the sides are. So the proportional perimeter theorem says if two triangles are similar, then the perimeters are proportional to, there should be a space right there, proportional to the measures of the corresponding sides. So if I have these two triangles right here, and they tell me that triangle LMN is congruent to triangle QRS, and they want me to find the perimeter of this little triangle. Well, L would be congruent to the Q, and M would be congruent to the R, and then S would be congruent to the N. Okay, so if you look at it, I know the measure on both of them between the 1 and the 3 arcs. So I'm going to set up my proportion problem. I'm going to do left triangle, and I'm going to do right triangle. And on the left triangle, the side that's between the 1 and the 3 is 12. On the right triangle, the side between the 1 and the 3 is the 5. And then if I find the perimeter of the left triangle, so I have 12 plus 37 plus 35 is going to give me 84. So the perimeter of the left triangle is 84. And what I'm trying to find is the perimeter of the right triangle. So then I've got a proportional problem here. So I have 12x is equal to 84 times 5, which is going to give me 420. And then I'm going to divide that by the 12, and it's going to give me x is equal to 35. Now, you have other theorems that are very similar to the perimeter theorem. You have this theorem that says if two triangles are similar, then the measures of their corresponding altitude. So this time it says the altitudes are proportional to the measures of their corresponding sides, just like the other one said perimeter. This one says if two triangles are similar, then the measures of their corresponding angle bisectors are proportional to the measures of the corresponding sides. So just like we had the perimeter, the altitude is proportional, the angle bisector is proportional, and this third one says the medians are proportional. So just like the sides are proportional, so is the perimeter, the altitudes, the angle bisector, and the medians. So, like for instance, in this particular figure, says if the figure triangle ABC, and I'm going to go ahead and mark the angles here, ABC is similar to DEF. Okay, so I've marked it according to that similarity statement. BG is a median of triangle ABC, and EH is a median of triangle DEF. Now, here's the thing. According to that theorem, then the median is proportional the same way the sides are. So I know that BC is 30, BG is 15, so there's your median, and I know that EF is 15. So if I do left triangle, right triangle, I know the measurement here between the 2 and the 3 arcs on the left is 30. Between the 2 and the 3 arcs on the right is 15. I also know the median on this left triangle. It's 15. So I want to know what the median, so this would be x here. So I cross product again, so I've got 30x is equal to 15 times 15, so 225, and I'm going to divide that by 30, and I'm going to get x is equal to 7.5. So that is going to be the measurement of EH. So EH is 7.5. Let's do another one. Okay, in this figure you have EFG, so I'm going to mark that. You've got E, now you've just got that little triangle right here, EFG is similar to J, K, L, and it says ED is the altitude of this triangle. So here's this triangle. The altitude is vertex perpendicular to the opposite side. You see how they had to extend the side. So this is going to be perpendicular right there. And it says JI is the altitude of triangle JKL. So again, they extended this and they dropped the perpendicular line down. Says find x if EF is 36, ED, which is the altitude here, is 18, and JK is 56. So I'm going to do left, right. So between the 1 and the 2 hash marks on the left is 36. Between the 1 and the 2 hash marks on the right is 56. The altitude of the left is 18. So we'll let the altitude of the one on the right be equal to x. So I cross product. I have 36x is equal to 56 times 18, which is going to give me 1008. I'm going to divide both sides by 36, and I'm going to get x is equal to 28. So that's going to be the altitude of that triangle. All right, your homework on this is page 320 through 322, 10 through 26 even. Just remember the perimeter, the altitude, the angle bisector, and the median are all proportional the same way that the side is.